For the purposes of this presentation, attention will be focused on one specific thinker whose groundbreaking ideas concerning the demarcation of science continue to hold substantial influence in Western academia and in the study of science. Karl Popper's contributions, however, are not restricted to questions of scientific demarcation. He was also a very prominent ethical and social theorist as well, with his seminal work, The Open Society and Its Enemies, ranking side by side with The Logic of Scientific Discovery as an iconic piece of work in the Western rational tradition. In order to grasp the full consequences of the paradigm shift he ushered in, some context must first be given as to the state rational thinking found itself in, right before his ideas were first published. The most common perception of what obtaining truth is to most people is known as verificationism. From searching up a word or phrase in the dictionary, to fact-checking one's ideas on the internet, to scientists testing their theories through experimentation, we overall try to verify our assumptions in our day-to-day activities. And at the turn of the 20th century, rational thinking was dominated by a group of thinkers based in Vienna who adhered to a very rigid form of dogmatic verificationism, known as logical positivism. The Vienna Circle, as they were called, devised this doctrine in Europe in the mid-1920s. Guided by the writings of Wittgenstein, Ernst Mach, Newton, and others, their task was as simple as it was ambitious. They wanted to once and for all put a complete and total end to all philosophy as we know it. They hoped to achieve this utopian aim by proving all problems of philosophy to be empty pseudo-problems, and therefore not worthy of serious consideration to begin with. Incidentally, this view and the corresponding sentiments are still quite common to this day. We had just two axioms. Things can either be true by definition, or they can be verified through direct observation. For them, it is only those observations, which could be subject to rigorous logical examination, that had any real truth content. Things akin to ethics, aesthetics, and most notably, metaphysics, had no meaning to them. It is important to note, however, that they never judged these things as wrong or incorrect. To them, they weren't even worth considering being judged as correct or incorrect to begin with. Their aim was then to separate the supposed kernel of truth from all the gibberish and nonsense that surrounded and obstructed it. This positivist extremism, as one could imagine, was rather utopian in nature, and in our narrative, they'll just serve as a punching bag that different thinkers of science will use to train their ideas on. Since they put so much emphasis on direct observation, they adhere to a bottom-up or inductive approach to reasoning, where a general premise would be formed only after consistent and thorough observations. Adhering to this form of logical thinking, despite its usefulness, had its difficulties. The question whether inductive inferences are justified, or under what conditions, is known as the problem of induction. As Hume pointed out centuries earlier, the potential for future observations to be inconsistent with previous ones makes coming to a general premise with complete certainty all but impossible using inductive inferences, as it is always possible for future observations to contradict past observations. It then goes without saying that trying to adhere to a form of verificationism with this kind of reasoning was going to be problematic, and difficulties soon arose in quick succession. Some thinkers, most notably Rudolf Carnap, noticed this ahead of time and retreated from the dogma of absolute verificationism to the weaker dogma of probabilism. The goal then was no longer to verify a hypothesis with complete certainty, but just to show that it was more probable than others. This too also had many difficulties, with one of those being infinite regress. For if a certain degree of probability is to be assigned to statements based on inductive inference, then this too will have to be justified by invoking a new principle of induction. And this new principle will in its turn will have to be justified, and so on. Popper was able to show, through painstaking work, that the mathematical probability of all theories, irrespective of the evidence at hand, would always be zero. Thus, probabilism would fail as much as verificationism. Although it is probably worth mentioning that there are still people around today who still continue to insist that probabilism can still be made viable, using Bayesian statistics. By the start of the 1930s, with all these difficulties continuing to mount, and of there being no remedy at hand, the situation seemed bleak for rational thinking. Inductive verification was not just unfeasible, but just showing a theory to be more probable than others also seemed to be a fool's errand. On top of that, the state of affairs around the world was also not very encouraging. At that point, it seemed as if irrationality had won. Separating genuine truths from bogus superstitions seemed impossible. To be more precise, separating science, the most respectable form of wisdom, from opportunistic deceit and unwanted sophistry seemed unachievable. It is against this backdrop of intellectual uncertainty that Popper and his falsificationist doctrine makes its first debut. Popper's remedy to this situation was to turn the entire script upside down. Instead of inductive verification, you instead get falsification. Or in other words, a real scientist doesn't try to prove their theories right. Instead, they try to prove their theories wrong. A proper scientist, wanting to know whether or not all swans are white, isn't going to go searching for white swans, but will rather go searching for black ones instead. The goal is always to overthrow one's hypothesis, not verify it. Falsificationism, as this doctrine is known, was in a sense a new and considerable retreat for rational thinking. But since it was a retreat from utopian standards, it cleared away much hypocrisy and muddled thought, and thus, in fact, it represented an advance. Despite his retreat from inductive verificationism, Popper still recognized the usefulness of inductive reasoning in the actual practice of science. He just thought its use wasn't necessary. In inductive verification, empirical data comes first, and from successive observations, a theory is then given. In Popper's falsificationist scheme, a conjecture is first given, and from successive tests, a conjecture can either be corroborated or refuted. It is important to note, however, that a theory can never be proven with final certainty. It can at most be corroborated, but it can never be verified. The usefulness of a theory is always provisional. In Popper's view, all scientific theories, even the most cherished ones, are conjectural in nature, and are always open to being proven false. Theories such as Mendelian genetics, germ theory, atomic theory, and Darwinian evolution, although very much prized today, are still open to potential refutation. This doctrine is a rather strange one. Definitive verification is never achievable in this framework. The much more modest title of corroboration is the most a theory can ever hope to achieve. It's important to note that Popper's account of a scientist who is always engaged in attempts to overthrow his theory, is an ideal that a proper scientist must measure up to. For Popper, a proper scientist must always be critical, or to use a more famous phrase, the theory must be made to stick its neck out. In the real world, however, the actual practice of science often diverges from this ideal. This would make Popper's view a normative theory of science, which in the future will stand in stark contrast to the more descriptive theories of science espoused by subsequent thinkers, which take more into account the actual history of the scientific field. This distinction will become important in the future, as it will put him at odds with thinkers such as Thomas Kuhn. What is perhaps his most important contribution to this field was in defeating the verificationist dogma of the day, undoing the stranglehold it held on rational thinking at the time. But in doing so, he replaced it with his own falsificationist dogma, and this came with its own new set of issues. Although discussing all that is beyond the scope of this video, and will have to wait for future presentations.